Hi everyone, this is lesson 5.2, exploring quotients of polynomial functions. A rational function is a function where it can be written in the form of p of x divided by q of x, where p of x and q of x are both polynomial functions. And from previous experience, we know that q of x cannot be equal to 0, and that becomes a restriction. The restrictions are rules that stated in which values domain could be or could not be. And this is a key characteristic that defines the shape of rational graphs. There are three types of asymptotes. They're horizontal, vertical, and oblique. Usually the end behavior depends on the horizontal and oblique asymptotes. Let's look at example 1 from your learning resources. It asks us to find the vertical asymptote of the following function and restriction for the following graph. We have f of x equals to 2x to the power 4 minus x squared plus 1 divided by x squared minus 4. The first thing that we can do is factor out x squared minus 4. And we know that can be factored out to x minus 2 times in bracket x plus 2. For the restriction, the bottom cannot be equal to 0. Therefore, x minus 2 times x plus 2 in bracket cannot be equal to 0. That means x minus 2 cannot be equal to 0, or x plus 2 cannot be equal to 0. And that will be our vertical asymptote as well as a restriction. So the vertical asymptote is that x equals to plus or minus 2, and the restriction for the domain is x belongs to all real numbers such that x cannot be equal to plus or minus 2. Let's take a look at example 2. Find the vertical asymptote of y equals to x over x squared minus x minus 6. Once again, we start out by factoring. X squared minus x minus 6, and that's going to be in bracket x minus 3 bracket closed times in bracket x plus 2 bracket closed. We know that the denominator cannot be 0. If it is, then we will have an asymptote. So x equals to 3 is an asymptote, or x equals to negative 2. A reaction function has a horizontal asymptote only when the degree of the numerator is less than or equal to the denominator. The horizontal asymptote will be equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. Let's take a look at an example that illustrates that. So it asks us to find the horizontal asymptote of y equals to x over x plus 4. Oops. We see that the degree of the numerator equals to the degree of the denominator. Therefore, we will have a horizontal asymptote. The leading coefficient of the numerator is 1, and the leading coefficient of the denominator of the highest degree is also 1. Therefore, the horizontal asymptote will be y equals to 1 over 1, and that's going to be y equals to 1. When a rational equation has a slant asymptote, that's the oblique asymptote, the degree of the numerator will always be 1 more than the degree of the denominator. If that happens, we will use long division to find out the equation of the slant asymptote. Find the slant asymptote of the curve y equals to 2x cubed minus 3x squared plus x minus 3 divided by x squared plus 1. Notice that the degree of the numerator is 1 more than the degree of the denominator. So we use long division that we have already talked about in previous lectures. I will not go through all the steps again. It is listed here on the slide if you're interested in looking at it. So the final answer we get would be 2x minus 3 with a remainder of negative x. Thus, y equals to 2x minus 3 minus is minus because it's negative x minus x over x squared plus 1, and this number came from here, x squared plus 1. So in conclusion, the slant asymptote is 2x minus 3. So that's the end of this lecture, and I'll see you guys next time.